Year 8s, welcome to a video about solving equations. In this video we'll learn how to find values for our unknown values in equations that we've been representing with letters. So I think we've touched on this topic a little bit throughout the year so far, but we're going to focus on it now. So when we say solve, what do we mean? Essentially, when we're saying solve for x, like we are here, we're asking to find a value for x, or we're being asked to find a value for x. So we need to work out what this x value must be in order for this whole equation to make sense. So in this little speech bubble up here, I'm just going to write find a value for. Hopefully you can read my writing there. Sorry, it is a bit of a dodgy iPad or a dodgy pen, I'm not sure, but hopefully you can still read what I'm trying to say there. So we want to find a value for x that will make this whole equation make sense. But before we think about finding the value for x, what I want us to do first is just focus only on this part of the equation here, 3x plus 9. And I want us to think about what has happened to x, so just x by itself, in order to get to 3x minus 9. So first of all, we can see that x has definitely been multiplied by 3 because there's 3 groups of x there. So we'll say that it's been multiplied by 3, and that gets us to 3x. And then we can say, well, what happened to 3x in order to get to 3x minus 9? We'll then say that we minus 9, and that got us to 3x minus 9. So first of all, we multiplied by 3, and second of all, we minus 9. So I'm going to write that again a little bit neater over this side here. So we started off with x, and then we multiplied by 3, and then we minus 9, and then that got us to 3x minus 9. So we're working this way. Now if we want to get from 3x minus 9 back to x, we can just work backwards and do the opposite. So if we minus 9 second, then in order to reverse that, we can just add 9. And then if we multiplied by 3 originally first, then we can just divide by 3 in order to reverse that, but after we've re-added the 9. So in order to backtrack what has happened to x to get to 3x minus 9, first of all we'd add 9 to reverse the minus 9, and then we divide by 3 to reverse the multiplication by 3. So you just do the opposite of what happened originally. Now that we've done that, we're going to think about the whole equation again. And we're going to think about it when we solve for x algebraically. So I'll just write this out again so we can work with it. We've got 3x minus 9 equals 15. So if we want to get x by itself, the first thing that we said we had to do up here was add 9, and that'll reverse the minusing 9. So we'll just say we're going to add 9 over here, and that will reverse the minus 9. Now, because this is an equation, whatever happens on this side also has to happen on this side. So if you think about, for example, you've got 5 equals 5. This is just a separate example. If you were to add 1 on this side, you'd have 5 equals 6, but obviously that doesn't make any sense. So you'd also have to add 1 on this side, so on the other side of the equal sign, in order for the equation to make sense. Now you've got 6 equals 6. So it's the exact same over here. Whatever happens on this side also needs to happen on this side. So we've added 9 on the left-hand side, so that means that we also have to add 9 on the right-hand side. And then we can rewrite our new equations underneath, or our new equation underneath. So on the left-hand side, 3x minus 9 plus 9 is just going to be equal to 3x, because if you've got minus 9 and you add 9 to it, then you get 0. So 3x plus 0, which is just the same as 3x. So 3x is equal to, and then we've got 15 plus 9. 15 plus 9 is equal to 24. So now we've got 3x equals 24. Now if we remember back to up here, the second thing that we had to do was divide by 3 in order to get back to x by itself. So we'll do that to this side here, we'll do 3x, and then we'll put divide by 3 underneath. You can write your little divide symbol and 3 as well. I just prefer to write a line and then 3 underneath. So both of those things mean divide by 3. It's the exact same as if you've got 1 divided by 2. That's equal to 1/2. So the divide by 2 is the same as the line and then the 2 underneath. And then back to our equation, remember whatever happens on the left-hand side also has to happen on the right-hand side. So we'll do 24 divided by 3. So now we can clean this up a little bit. So remember, when we've got a number and it's next to a letter, we know that that number is secretly multiplying the letter. So 3 times x. So if we've got 3 times x divided by 3, the 3 times is going to be cancelled out by the divide by 3. So we'll just be left with x. Another way to think about that is that you've got 3 on 3 times by x. So this 3 is this one here, this 3 is this one here, and x over here is this one here. If you were just looking at this fraction here, 3 on 3, you'd know that 3 on 3, or 3 divided by 3, just cancels down to 1, so you'd just be left with 1 times x, which is the same as x. Now we'll look at the right-hand side of the equation, and we've got 24 on 3. So if you think about it in fractions, you'd know that 24 on 3 would simplify to 8 on 1, or just 8. Or you'd also know that 24 divided by 3, which is what this line here means, 24 divided by 3 is equal to 8. So therefore, x must be equal to 8. And you can verify this by then substituting this value back into this equation. So if you think about 3 groups of 8, you'd know that that's 24. And if you then minus 9 from 24, you'd be left with 15. And what do you know? This side of the equation here is equal to 15. So that must be the value for x. What I want you to do now is have a go at A, B, C, and D. And then if you'd like a little bit of a challenge, which I reckon you're up for, go for this one. And then this one here is a bigger challenge question. So definitely everyone do A, B, C, and D. And then if you feel up for it, have a go at E. And then if you feel up for it as well, go for F. Just a heads up, with this one here, you might end up with a fraction as your answer. So if that does happen to you, don't worry, you're definitely on the right track there. See if you can remember how to work with fractions like we did in term 1.